Welcome to Bite-Sized Data Science. In today's video, we have a guest speaker, Robert Uleman, that will talk about what to do when you need to deal with too much data or too much details in your data. Without any more delay, here's Robert.
Hi everyone, I'm Robert Uleman, data science engineer for IBM Data and AI. I work on short-term data science projects helping customers on the road toward becoming AI-driven businesses. A well-worn quip about data scientists says that we spend 80% of our time preparing data. In my experience, I don't know about the exact percentage, but that sounds about right. As a data science engineer, I live even more of my life in that space, and there's value in it, even if it doesn't sound as exciting as talking about the magic of XGBoost and TensorFlow. Today, I'd like to talk about what happens when you get more data for your machine learning project than you can productively use. This is based on a customer engagement that I did last year, where we were given a lot of data, multiple tables in multiple files per table. It was several terabytes uncompressed, not quite big data perhaps, but then we also weren't working with big data resources. We spend most of our time just dealing with this volume, trying to understand and organize it, and whittle it down as much as we could to prepare it for model building. And we did it using Python and Spark in Jupyter notebooks. Ideally, a lot of this would have been done in the database from which the data was extracted, but sometimes you just have to work with the tools at your disposal and the data as provided. After a lot of trial and error and waiting for code to run and finish, we ended up with some reusable code that will make our lives easier the next time around. I can tell you a little bit about the distinct aspects of this kind of data wrangling that we address in that code. Every case is different, of course, but some tricks and techniques will come in handy every time. This project was about customer churn, so what to do about customers who might leave for the competition? Can you predict who's about to leave? Can you suggest some action that could change their mind? The customer was a telecommunications company. So you have a table about users and what kind of services they have, and a table with their history of call, text, data usage, and various other tables. And you need to put that all together to create a training set for your modeling effort. But if there's so much data that first, you can't read it all into memory, and second, it takes forever to read each file, and you have a lot of files, then you can't really make any progress. In what is usually a very iterative process of figuring out what needs to be done to the data to get it ready for machine learning, you need a volume of data that gives you quick turnaround on your experiments, but still has enough of the characteristics of the full data set to keep you from chasing sampling artifacts. And that is all before you even get to the part of proper feature engineering. Now, there are two main aspects to this story. One, too much data overall, and two, too much detail. For too much data, the answer is obvious. Use sampling to create a subset. So obvious that there are standard methods for it in packages like Pandas and PySpark. But there are wrinkles in cases where the data is in multiple large files and because you're dealing with churn. This is the subject of another video. The solution to too much detail is you're going to have to aggregate. What we had in this case was daily detailed records on customers and their activities. And we had 10 months worth of that. So if you have, as we did, 8.5 million customers, at 300 rows per customer, that's roughly 2.5 billion rows in every table. The good news is that aggregation doesn't just reduce the volume, it also makes the data more meaningful. Patterns from month to month can tell you more than daily variations, which are mostly just noise. Now, we have a process in which data goes through the following steps. Creating a subset of the customers, and then using only that subset in the following steps. Merging all files for all tables, aggregating from daily to monthly, and while you're at it, applying basic transformations and dropping unwanted columns. Each of these steps can take a lot of different forms. Some files can be merged by joining, which results in additional columns. Others by unioning, which adds rows. Aggregation can use different aggregate functions, numeric values by, say, a sum or max or mean function, categorical and more or less constant values, such as which plan the customer has, by simply taking the most recent value. An example of a basic transformation is to take just the year from a date column. That may be all you need to know to distinguish, say, long-term customers from newly joined ones. Turns out that all these steps can be done in one pass if you use Spark. Our notebook simply specifies all the operations in a way that makes sense when reading the code. Spark figures out the best execution plan and delays any real work until we ask for the final number of rows or write the result to a file. Our work was successful, and it is now very easy to rerun the whole pipeline with different choices and different subsets. That makes the next steps, feature engineering and model training and tuning, much more productive. When you see your efforts to tame the data bear fruit and turn into beautiful models, and when you realize that you can use or reuse that code in your next project, all that data wrangling work is worth it. I'm making the code available so you too can apply it in your next project. I hope you find it useful, and maybe you will even appreciate those 80% of your time chores as rewarding in their own right.
Please look at the description of this video to find a link to Robert's code. This way you can take advantage of proven tricks and technique. See you next time on Bite-Sized Data Science, and don't forget to subscribe.